Thank you, Karen, and I welcome you all, distinguished guests and participants. I first apologize for my throat. I have a sound problem, but I think it will not be too much. The title of my presentation is Application of GIS in Smart Water Resource Project Monitoring in Bangladesh. In fact, this is an applied project which will impact on water resource monitoring in Bangladesh using GIS technology. Now I give a small background. You know, Bangladesh is a small country, but it is carrying huge amount of water which comes from Ganges, Brahmaputra and Meghna basin. Total basin is very big, only its 8% area is Bangladesh. And this is the river you see in Bangladesh. I think no other place except Amazon, so many rivers in country like that. And we are living with those rivers. That is why water resource management is very important in our country. Normally, that means each year expected area of inundation is 20 to 25%, and we expect about 40 to 45% in 1 in 20-year return period flood. If all the water which in average year flows through Bangladesh is stuck, it is Bangladesh will be under 25 feet deep all over Bangladesh. This is the quantity of water we have to handle. That is why Bangladesh Water Development Board under the Ministry of Water Resources has many initiatives over half of centuries, even about 70 years, to build up many protection projects from water disaster. That is, we manage the flood, we control the flood, and we live with flood. Flood control and protection projects are there. Mainly two categories, two ways we manage the flood: structural and non-structural. Under the structural measures, we build more than 460 plus water resource projects. Those are being managed by Bangladesh Water Development Board regularly. And non-structural measures, sorry, excuse, flood forecasting and adaptation. Here you see we have GIS based application we developed for Water Development Board. The points you see are the measuring points of water every day, and we forecast what will be the next day and day after tomorrow water levels, and what will be the inundation, expected inundation. Accordingly, the inhabitants besides the river or floodplain, they can take their necessary measures. This is called non-structural, because in that we are not really intervening the flood. For example, in one gauge station where water level is measured, this is from real-time sensor-based data. Every 15 seconds, this hydrograph is being updated. This is the background. You see the structures, that means the projects, water resource project all over in Bangladesh, and this was the study area. You can see my mouse movement. For that part of the Bangladesh, we have developed that smart project monitoring system. We call it SIMS, means Smart Project Information Monitoring System. The overall objective was web-based smart information monitoring system for managing and maintaining the BWDB schemes and projects spread over the country. The specific objectives were to develop web GIS based water management schemes, develop system to collect disseminate relevant information by devices, and then assess the information management system. And the developed component were scheme database, SIMS web-based facilities for visualizing scheme information system, smart device-based data collection system. We developed GIS-based mobile apps through which we collect the data in real time. It is updated in the server and it can be seen on the screen. And then we have connected flood forecasting information at scheme level, because forecasting is done at river gauge locations. From there, it is translated to water management structure level to estimate the threats of flood. Will this structure can handle this level of flood or not, so that the infrastructure manager can get help. And then integration of auto gauge water level. This is specifically useful when there is a cyclone forecasting or flood forecasting is there. So every 15 seconds, those are visible on the screen. And asset management system, which is one component of ArcGIS that we have utilized here. This is our dashboard, and you see here 9 components, 9, 10, 11, 12 components are there. One is real-time monitoring here. So real-time gauge reading, that means water level data comes in the chart and it shows the threat level of embankment and the local community. In that way, water board is serving the local community also. Now we go live. Before that, I show you one screen. Here you see in a scheme there is one window. If any field engineer, he like to inform that something happened in the site, that means one embankment has been broken and some repair is required, he can take a photograph, he can send SMS through this interface, he can send an email, and a report will be automatically generated and sent to the relevant higher officials to take emergency actions. And also you can see that there are some Skype icons. Clicking those one, a specific 4 persons can be contacted directly through Skype, which is integrated with this application, because people are very frequently using this technology for communication. Through Skype, you can visualize the situation, inform it to higher manager. Here one example, you can see that this is the person who is making a call showing this sluice gate. Now we go a bit live, small 1 or 2 slides. I think I'll show you. This is the first screen of scheme information management system. Our study area is here in Chittagong, and if I go there, there are BWDB schemes. Projects are here. Scheme layers are here. If I put this zoom off, now you can see the schemes. These we call scheme. Embankments, canals, protective works, and hydraulic structures. These are protective works. Hydraulic structures are here. I go here. This is a canal which has been built for irrigation purpose. So if I click on this canal, we can see the canal situation, the canal photograph, and video will be also there. It is there, but it's not still rendered. We can see structure will come here, and if we click on any structural element, hydraulic structure, canal, or embankment, we can see the design parameters and photographs, and there are about 18,000 hydraulic structure all over Bangladesh. Those has been surveyed, all their parameters has been entered into the database, and if in any place repeatedly erosion happens, for example, then decision makers can go for a study in that area elaborately what is the reason. That can be visible from this screen. So I will move to the next. This is from where real-time water level comes from the sensors. Sensors are placed here. The green sensors shows data is receiving from these stations. When it is red color, sensor is not getting the data for some reason. It is here. And you can see a small video of that sensor related data collection system. You can see the gauge number and the water level. Here water level is available. Water level is shown there, and I'll show you one. You see, this way the level is always it is being updated, and it is updating in server as well as it goes for GIS mapping. This mobile app has been developed for iOS and Android for collecting data from the field. These are the data, selecting zone after that one. In that way, it goes to the database directly. Then we have done capacity building because we work for development, and government authorities, BWDB authorities, they will apply it in the field. So we have trained them. In this, we have applied the technologies ArcGIS Server Enterprise 10.5 Oracle 12c that was used for data storing. Real-time communication, IP camera, SMS, Skype was used. Mobile application, Sims mobile app we have developed. And then mobile vehicle tracking was also done. GIS map of BWDB scheme was main output. Oracle database was there. BWDB asset information. These are the outputs and outcomes. And FFWC information integration, that is a separate project but we integrated to translate from river to the scheme level. The future expansion scope is that it should be replicated to other areas. Government has taken already the initiatives, and dynamic flood mapping is a scope that when we get the sensor level, water level, dynamically it will show the flood extent. That area we will be working in future. Real-time estimation, visualization of the qualitative and quantitative flood. And then we have done impact assessment. It can be done in many ways. We have considered resource, time, cost, and safety levels. In the study area, more than 2.9 million people are directly getting help from this 43 number of BWDB schemes. And for that monitoring, it is highly required because there are some examples that I can show you small video.
মাদারীপুরে কালকিনি ও বরিশালে গৌরনদী উপজেলার সীমানা বাকাই গ্রামে একটি স্লুইস গেট নির্মাণের জন্য পানি উন্নয়ন বোর্ড বরিশালের
I tell it in English. There was a hydraulic structure for monitoring or maintenance purpose. Government has allocated some money, but contractor left the work behind and taken away the money. And people, they were suffering from the communication because the same structure is used for communication also. But with this smart monitoring system, they can see it from remote through IP camera, and they can monitor the work progress and pay accordingly. This system will help to avoid this kind of situation. Now we have done a small impact assessment. It was a location, site location, and office is here 86 kilometers away. So if in each year the site is visited, 2 person goes there and come back, transport cost is there, and there are other cost, DA, daily allowance. Total cost comes for 5 year, it is 157 taka per day is costs. But if this Sims Smart is applied, we have estimated that cost, it came down to 27.75 taka, which is 82.3% reduction of cost. But there are many other peripheral advantages. When the people became aware of flood level, they can save their life and properties. That is invaluable. So in that way, application of GIS in this smart monitoring system is helping Bangladesh to achieve the Vision 2021 goal, Digital Bangladesh. And we are going forward. Right now, I say that we have submitted this project in January 2018, but government process is always slow in developing countries. You see the photographs here, our water minister, water secretary, they sat in a meeting on 1st September, just 2 days before, they called um, all the related officials to replicate this developed system to entire Bangladesh. That means Sims Smart is in the mainstream of Bangladesh using this Esri product as its supporting tool. Thank you.
Thank you, Dr. Aled. So we have a few questions that came in.
Yes. Future plan I have shown in a slide that to replicate this system to entire Bangladesh, now it is for only a small part, and also to add some more module, that is one is dynamic flood mapping that will help the flood prone people to save their life and properties in real time. Who could be the other users besides BWDB? This is general people residing inside the water management project, even outside, because if they know that water level coming here, this my area will be flooded by this height of water, they can decide, they can prepare themselves for preparedness work, flood, disaster preparedness during flood and post disaster. This information can be used. We have used sensor-based data, not satellite image so far.